Hey guys, if you wanna join our VLSI design and verification training program, you can contact us, and contact details are inside the description box. So guys, our today topic is array. Means today we will discuss about all type of arrays, whether Verilog arrays or we can say System-Verilog arrays also, because some of them arrays are common in both languages, right? So before going to start, first of all we need to understand that what are the arrays, right? So arrays are group of same type of elements, means the homogeneous element, right? If you wanna say the homogeneous element, then we should go for arrays, right? That is the one thing. What is the second application? Mostly used to create the to store the data, or we can say to create the memory. Let's say I want to store some data, like I have 20 student and I also want to save their high school percentage, right? So how we can do that? We can use some array. So inside array we can use the student name as the index and the data element will be their percentage, right? So in such a way we can store that information, right? So if you find such a scenario somewhere, so directly we can go for arrays, right? Data can be stored index wise, as I described you with the example, right? So index will be the memory address and data will be the element stored onto that address, right? Now we'll see, we have done with the arrays, right? What are their application, and now we'll see the type of arrays, right? So first one is fixed size arrays. So we can categorize in many way, right? Their behavior, their size, memory utilization, all kind of thing. So I am mentioning here fixed size arrays. Single dimension, or we also called in short 1D array. Then 2 dimension, also called 2D array. Then 3 dimension, also called 3D array. Then 4 dimension, also called 4D array. Another one is, there is a term, something called packed or unpacked array. Next one is dynamic array. Next is associative array, and next one is queues. So we have to cover so many topics, so we will divide this lecture into multiple subparts, right? And we will discuss all of the arrays, right? So first let me go for fixed size array. Array size will be fixed during the complete simulation time. Means once you declared the array, right, after that array declaration means their size and their means how many location it can consume, right? So once you have done with the declaration, the whole simulation time, whenever the code run, so the size will be same, you cannot change, right? All things will be fixed as the name, fixed size array, right? It may be packed array, it may be unpacked array, right? So let me tell you what is the meaning of packed array, right? So it means dimension declared before the element name, that is called packed array. Like let's say I am writing bit 3 down to 0 data. So here data is the element and 3 down to 0 is the dimension. It means it can store 4 bit onto a single location, right? So now let me write a small code, module top and module, and here I am writing bit 3 down to 0 data, initial, begin, end. Here array initialization. How we can initialize? We can directly write data is equal to, let's say, 12. After that dollar display, here I am writing data is equal to percentile d data. That's it. We have done with our first array code. Select the tool and now we can run this code. So here we can see the output is 12, the same thing what we have stored in the array, right? So now let me describe you what is the mean of that array. We have written bit 3 down to 0 data, right? So this is actually 1D packed array. 1D means single dimension. So how it will look like? So this arrow is pointing toward the single location, and these are the fields. Means this is data of 0. Data of 0 will be stored over here. Data of 1 will be stored over here. Data of 2 will be here, and data of 3 will be here, right? So in such a way we can store the all four values. Okay. So here we have done with the first small code of array. Now do some variation. Let's say 2D packed array. So it will be like bit 3 down to 0 and 7 down to 0 data. So it will look like this. It means total having 4 continuous location because they are packed, right? And every location can store 8 bit of data. That's it, right? Means it will be look like so I have written bit 3 down to 0, 7 down to 0 data. Both things are packed. Packed means continuous. Simple. So it will be like so here it is bit of 0, it is means we can say not bit data of 1, and here it is data of 0, data of 2, data of 3, right? So these are the location. That is my first location, that is second, that is third, that is fourth. 3 down to 0, that means 0 to 3, total number of 4 location, and every location can hold 8 bit of data. It will be look like this. Right. So the segment will be like this in every section. It will be like this, right? Means here it is also 8 bit data. Here is also 8 bit data. Here is 8 bit data, right? So that is the packed. Means if you have declared both dimension before the element name, so the location as well as the size of each location both will be packed actually, right? So module top and module bit 3 down to 0, 7 down to 0, data, initial, begin, end, for each begin, end. Inside that, data of I, data of I is equal to I plus 1. Dollar display data of percentile 0D is equal to percentile 0D, here I, and data of I. Let's run this code. So here we can see data of 3 having 4, data of 2 storing the value 3, data of 1 means these are the locations 3, 2, 1, 0. So all the locations having some values, right? Now after that, guys, I have a small assignment for you. Just pause the video over here, right? And the thing is, let me copy this thing. So that is the output of this code, right? So your assignment is how to inverse the index of above. Means it is in ascending order. It is in descending order actually. Let's do it on ascending order, right? Means you should only go for each loop, and you should write some small logic like the order of the index will become changed. Means first of all, the print will be like data of 0, then data of 1, data of 2, and data of 3, right? So just do the assignment and make some good comment, right? And now the next thing is there is something called size method. Size method. So module top and module bit 3 down to 0, 7 down to 0, data, initial, begin, end. Here I am writing for begin, end, int I is equal to 0, I is less than dollar size of data, then I plus plus. So what it will do, Dollar size is a inbuilt system task, so it will automatically check the size, the depth of the array, right? The number of locations, right? Location by itself. Here I can write data of phi is equal to, let's say I'm writing I plus 1. Dollar display data of percentile 0d is equal to percentile 0d I and data of I. Let's run this code. There is some issue. The error is coming from line number 4. Yes, that is I is equal to 0. So you can see data of 0 is equal to 1, data of 1 is equal to 2, data of 2 is equal to 3, and data of 3 is equal to 4. So by using dollar size, it can take size automatically, right? So now the next point is unpacked array. So it means dimension declared before the element name. So module top and module, and here let's say I'm writing bit data 3 down to 0. So that is 1D unpacked array, and having 4 unpacked locations, and every location can store 1 bit of data, right? So how it will look like? Bit 3 down to 0 data, right? So it will look like this. Like this. So it will be your they all will be your location. So it will be data of 0th location, and similarly it will be your data of 3rd location, right? So it will be like that, means unpacked structure. Okay. So that is 1D. So okay, initial, begin, and simply for each begin end inside that data of I, where I will represent the location. Data of I is equal to $random. $display data of percentile 0D is equal to percentile 0D I and data of I. So you can see these are the locations 3, 2, 1 and 0, and it is picking some 1-bit random data 0, 1, 1, 1, right? So that is 1D unpacked array. Now we'll go for 2D unpacked array. Module top and module bit data, after that 3 down to 0, 7 down to 0, initial, begin, end. Here I am writing for each begin, end, data of I comma j. Here both are the dimensions, right? I will represent the dimension 3 down to 0 and j will represent the dimension 7 down to 0. So data of I and here data of j is equal to, let's say I'm writing $random, then $display data of percentile 0D, percentile 0D, percentile 0D, here I comma j comma data of I and j. That's it. Let's run this code. So guys, let me tell you one thing. So it will show, first it will take the data of 3 and here it will pick the value 7. Means at the third location, the 7th width location, what is the data? It should be like that, right? And it is only capable to store 1 bit of data. Don't get confused. Here these both are the dimension actually. Here you can see data of 3. So you can see here data of 3 is constant and data of 7 is varying, means this j dimension is varying while I dimension is constant. So it is varying from 7 to 0 and it is holding 1 bit random data. Again, the dimension of I, that is here 2, and the dimension of j is varying from 7 to 0 with the random data, right? Again, the dimension of I become 1 and the dimension of j is varying from 7 to 0 with random data. The last one is the dimension of I becomes 0 and the dimension of j continuously varying from 7 to 0, right? So what it is saying, the location is third, on the third location, the 7th bit location, the data is 0, right? It is like that. So this is 2D unpacked array. Now I have one more assignment for you. How to store 4-bit data in 2D unpacked array. Okay, because the above code is only capable to store 1-bit data, right? So that is your another assignment. So guys, that is enough for today, and rest of thing we'll discuss about the next lecture. If you have any doubt, you can make comments, right? If you want to know more about the VLSI design and training program, so the email ID and the contact number are inside the description box. Okay guys, thank you.